Hi students, today we will derive torque experienced by a dipole which is kept in a uniform electric field. So this is dipole, one end is plus Q and one end is minus Q. So when there is a positive charge kept in external electric field, so these arrows are showing the external electric field. Okay. So the positive charge will experience force in the direction of E. So it will experience electric force QE in the direction of E, and this will experience force opposite to E, which is Q into E. So if you observe carefully, there are two equal and opposite forces, right? This is QE and this is QE in this direction. So this is here and this is here. If you observe, suppose this is a pen and these two are forces. So this will try to rotate here and this will try to rotate here. So this will experience a rotational force, which is known as torque. Okay. So we are trying to calculate. So what is the formula of torque? Torque is nothing but distance, the linear distance between the forces. The linear distance is this. See, this is the force and this is the force. So linear distance is this. So linear distance into force. So suppose the actual distance between dipole is this, between plus Q and minus Q. Okay. And this angle with horizontal is theta. If you look here, this angle is theta. Okay. So what is this distance? The linear distance between these two. This distance. So this will be nothing but, let me call it x. I'm showing you through this diagram. Let us see here, which is easy to understand. Suppose this is x. So can I say x by d is sine theta? I'm sorry. Okay, so x will be d sine theta, the linear distance. Okay, we never take the distance between the forces. We take the linear distance between the force. This is F1 and this is F2. So the distance between them is this. So this will be d sine theta into F. F is the force, which is Q into E. If we change the order, so it will be dq E sine theta. Can I write like this? I am taking just d with q and E and sine theta here. What is dq for a dipole? We learned it in the previous video. The product of a charge q and the distance between them is called P. P is equal to d into q, which is also known as dipole moment. Okay. So this is nothing but P. So can I call it P? Can I call it E sine theta? And what is this P sine theta? Is nothing but the cross product, correct? So torque is nothing but P cross. So this is the torque experienced by the dipole. So this is the torque P cross E. What is P here? Dipole moment. And what is the E? E is the external field. Okay, this is not the field developed by the dipole. This is the external electric field. Okay, here dipole will also create its own field, but we are ignoring it in front of the external electric. So every dipole experiences a torque. So in which condition torque is maximum or minimum? So this is the condition when the dipole is kept horizontally. Plus is in the direction of E. So this is angle 0. So what will be the torque? Torque will be PE sine 0, and sine 0 is 0. The torque is 0. So in this condition, the dipole will not rotate because it will experience no torque. So this condition is called equilibrium. Okay. Now, when the theta is 90 degree, so what will be the torque? It will be PE sine 90. And this is the condition the torque will experience. It will be the maximum. Torque is maximum. Okay. In this condition is also torque will be PE sine 180, right? Here now plus is kept away from the direction of E. देखिए, this is the direction of E. E is in this direction. Okay. And plus is here. So this angle is called 180 degree. So sine 180 is again 0. So torque is 0. So this is also equilibrium condition. Okay. This is also equilibrium. But there is a difference in these two equilibrium. In this case, this is a stable equilibrium. Stable means even if you disturb it a little bit, it will come back to its position. It would like to stay here. Plus matching with this and minus on the other side. And this is an unstable equilibrium. This one is also equilibrium, but it will be unstable. If you will disturb it a little bit, it will come back. It will not come back to its own position. For this, torque will be PE sine 270. Sine 270 is minus 1. So here will be also be the torque maximum, but in opposite direction. So these are 4 cases. In these two, we have minimum torque, and in these two, we have maximum torque. See you in next video. Bye everyone.